Inertia, the tendency of an object to keep moving in a straight line at a constant linear velocity.
When you break your car, suddenly you go flying, right? Well, hopefully you're wearing a seatbelt because that is the outside force. The seatbelt stops you from flying out the windshield. If not, then the windshield is the outside force slowing you down.
Acceleration, velocity changing over time.
An example of acceleration is when your foot uses the gas pedal in the car. When people press the gas pedal, you feel that the car is gaining speed.
Force is any influence that changes an object.
An example of a force is a tsunami. A tsunami pushes away everything in its way, or pushing a revolving door.
Balanced force. Two forces acting in opposite directions.
Balanced force. Example, textbook standing on table. The normal force of the table exerts on the book equals the force of gravity. Of velocity, when you're at a red light, your velocity, 0, and your acceleration is as well. When the light turns green, your car speeds up. You go from 0 miles per hour to 60 miles per hour in 5 seconds. Your velocity changes from 0 to 60, so 60 divided by 5 equals 12 miles per hour. Balanced force. Example, rocket rising up into space, the force of the upward thrust is larger than the force of a downward weight.
Mass, amount of matter in substance.
Mass. A person and object may be weightless on the moon because of the lack of gravity, but that same person maintains the same mass regardless of location.
The product of the mass of the velocity of the object.
Momentum. Product of mass and velocity. For example, a heavy truck moving quickly has a large momentum. It takes a large force to get the truck up to a specific speed, and takes a large force to bring to a stop. Afterwards, if the truck was lighter, then it would have less momentum. Newton's first law example. In a seat in your car, you are in motion, not rest. You're actually moving as fast as the speed of your car. If you were to stop immediately, you would continuously travel forward as fast as the car was traveling. Newton's second law. The law also states that if it gets twice the mass, it accelerates half as much. For example, pushing a 10-pound ball as hard as you can and pushing a 5-pound ball as hard as you can. The 10-pound ball would accelerate less because the ball has more mass. If you think of tug-of-war, when teams pull, they lean back and push with their feet while pulling on the rope. The action is pushing on the ground. The reaction is the ground pushing back. Newton's third law.